Gauss-Jordan elimination, and we're gonna set up like this. So that 1 1 1 goes on top, 1 1 1, then the 2 4 7 3, then 1 3 5 2, and of course the augmented is gonna be equal to 0 0 0. Remember, we have 4 vectors. That means that we can put one more. So the fourth one is going to be a free variable, as you will see. Okay, so the first step into doing, we're going to get rid of these two here. The way you do it is you do like this. You do minus 2 times I, then you do minus where I represents the first row, and then here we're going to do minus I, which I represents the first row. So that's going to equal to 1 1 1 1 0. Then we have minus 2, so that's 0. Then we have minus 2 plus 4, that's going to be equal to 2. Minus 2 plus 7, that's 5. Minus 2 plus 3, minus 2 plus 3, that's 1 0. Then we have 1 minus 1 0. Minus 1 plus 3, that's 2. Minus 1 plus 5, that's 4. And then minus 1 plus 2, that's 1 0. And of course the last one is 0 0 0 0 0. Okay. The next step is to get rid of these two here. So the way we do it is like this. We're going to do minus 2. Okay, so we're gonna do 1 1 1 1 0, then 2 4 7 3 0. Then we're gonna have minus 2, so that's minus 2 times 2, because we're gonna get rid of this one here. No, I'm sorry, we have 0 here, 0 2 5 1, 0 2 5 1, so minus 2. We're gonna do minus 2. Okay, so it's gonna be 2 minus 2, that's 0. Then we have minus 5 plus 4, that's minus 5, that's negative 1. Then minus 1 plus 1, that's gonna be equal to 0 0 0 0 0 0 0. Okay. Then what we're gonna do is we're gonna get rid of these. We're gonna get rid of these 2. So that way we're gonna do it is like this. We're gonna divide by 2, and we're also, once in these 2 steps, we're also going to get rid of this 1 here. So what we're gonna do it is like this. We're gonna do so we're gonna do plus I plus 3, because third row we're gonna add it to the first row. Okay, so that's gonna equal to, okay, so that will be 1 1 0 1 0. Then divide by 2, that's gonna be 0 1 5 over 2 1/2 0, and then 0 0 negative 1 0 0. Then we have 0 0 0 0 0. Okay, let's get rid of this 5.5. So what we're gonna do is we're gonna do negative. We're gonna do multiply 5/2 times 3, third row. and we're gonna add it to second row. Okay, so let's see. So it'll be 1 1 0 1, then 0, then 0 1, that will be 0, then 1/2 0, then 0 0 91 0 0. Then we're gonna get rid of this -1 and we're gonna get rid of this one here. So the way to get rid of this one is by doing negative. We're gonna add -2 the second row, negative times the second row, and then here we're gonna divide by -1. So that's gonna equal to 1 0 0, and then 1 minus 1/2, that's 1/2, then 0, then 0 1 0 1/2, 0, then 0 0 1 0 0, and of course here we have 0 0 0 0 0. The last one 0 0 0 0 0. And there we have it. We have a Gauss-Jordan elimination form. Okay. So now the vector orthogonal to this one. So basically orthogonal or perpendicular is gonna equal to like this. Okay, notice the first one is gonna be your x1. So this is gonna be x1 is equal to x2, x3, and x4. So that's gonna equal to x1 is gonna equal to if we move it to the other side, it's gonna be negative. So let's put x4 because x4 is on the bottom. Well, let's call it t. Notice x3 it's 0, so let's put 0. The next 2 is going to be negative 1/2 times t, which is x4, negative 1/2 t. Same thing with the first one, negative 1/2 t. And that should be your answer to this problem. When you want to find a vector, use Gauss-Jordan elimination and then set up your perpendicular vector like that as follows. So once you have this form, you can come up with this one by rearranging, by moving to the other side the variables and leaving the leading variable in terms of the other variables. And that's all you have to do for this problem. Thank you very much. Don't forget to subscribe, please.